Sublakshmi ma'am, kindly unmute yourself.
Sublakshmi.
Sir, unmute பண்ணிட்டேன்.
But the symbol has not changed.
Unmute பண்ணி. Unmute.
Sublakshmi, have you unmuted yourself? You have to unmute yourself. You can also start your video. Yeah. Unmute. Still it is mute. Audio is in under mute.
Now it's okay, sir?
Yeah, yeah, it is unmuted.
Okay, sir.
Wow.
Yeah, Professor Venugopal, we will start now.
Yeah, I am ready.
Reverend Dr. Henry Jerome, Rector, St. Xavier's Institutions. Reverend Dr. Alphonse Manikam, Secretary, St. Xavier's College, Palangotai. Reverend Dr. Das, Principal, St. Xavier's College, Palangotai. All officials of the college, my dear colleagues, Raj, head of the department, and dear participants, good morning to you one and all. On behalf of St. Xavier's College, Palangotai, we welcome you all to take part in the national.
Your voice is breaking.
On modern options reducing Microsoft Excel conduct. We welcome you all for a one-day national seminar on modeling and solving optimization problems in operations research using Microsoft Excel and Solver. For this national webinar, the resource person is Dr. Venugopal, our illustrious and industrious alumnus of St. Xavier's College, Palangotai. Today's session will be moderated by Muthulakshmi. She is our research scholar in the Department of Mathematics and Xavier's College, Palangotai. Over to Miss Muthulakshmi, she will now introduce the resource person and invite him to deliver his lecture. Muthulakshmi, Subbalakshmi.
Yes, thank you, sir. A warm good morning to one and all. It gives me immense pleasure. Welcome everyone for this national level webinar on modeling and solving optimization problem in operation research using Microsoft Excel and Solver. Some personality needs no introduction. Their excellence speaks for themselves. It's my honor to welcome such an eminent personality, former best outgoing PG student of St. Xavier's College, Palayamkotte, Dr. D. Venugopal, Professor of Mathematics and Control of Examination, formerly Director in Research Publication and University Press, formerly Head Department of Mathematics, formerly Dean in Arts and Humanities, Sri Chandra Sekhar Kendra Saraswati Vishwa Mahavidyalaya, deemed to be in University, Kanjipuram. A warm welcome to you, sir. A warm welcome. Time flew in his presence without our being aware of it, as quoted by one of his students, stand testimony for his rich 22 years of teaching experience. He has passed CSIR, UGC NET, PGDCA. He is also has certificate course in Hindi and spoken Sanskrit. He is the recipient of prestigious CSIR Junior Research and Fellowship. He has guided 21 MPhil scholars and 10 PhD scholars. His interest in research is varied. He has an interdisciplinary research interest in management, computers, and Sanskrit. His research publication includes he has published 33 publications in peer-reviewed journals and 14 Scopus Index journals. He is an author of 6 books. He has authored more than 6 books. A humble human being who has a deep root in spirituality. His administrative skills can be demonstrated in the following areas. He has he acted as a control of examination in SES, SPMB, Director of Research and Publication for 5 years in SCS and SPMB, member Board of Management, member in Planning and Monitoring Board for 2 years in SCS, SPMB. He is also Dean in Arts and Humanities for the 2 years. He has served as also at Department of Science and Humanities for 5 years. His administrative skills list goes on and on. His accomplishment list he has many feathers in his cap, and this also includes even this pandemic has not stopped his excellence. His thirst for knowledge has continued. He has also updated his YouTube channels and given many talks, webinar talks on his YouTube channels. You can also visit his YouTube channels to have an enlightened talks in the topic real life school mathematics, basic graph theory with GRNIR and ICT tool, solving transportation problem with Microsoft Excel and Solver, benefits of Manavala Kalai, introduction to unity of faith, so its spirituality, and it has been involved and has been demonstrated in his teaching also. He is a man of few words, and his excellence speaks for himself, and it's my privilege and honor to introduce such an eminent resource person of today's webinar. Thanks a lot. Welcome you, sir. A warm welcome, and we are honored and humbled with your presence. Thanks a lot, sir. Hello.
Yes.
I would like to hand over the session to our resource person, Dr. Venugopal, sir.
Hope I am audible.
Yes, sir, you are audible.
Yes, audible, sir.
Yeah, yes, sir. Yes, sir, you can proceed.
Sir, it's not audible.
Somebody muted me.
Mr. Vincent?
Sir, lot of echo, lot of mics on. Kindly all of you mute yourself so that my voice is clear.
Lord sir, I think you have two devices you connected with nearby.
Yes, some echo is seen.
Maybe some of the people you have two devices nearby. Kindly unmute and reduce.
Kindly mute.
Sorry, mute yourself and reduce your voice also.
Yes, shall I proceed?
Yes, sir. Go ahead.
Yeah, this is with the thanks to St. Xavier's College, Palayam Kottai for having arranged this. I did MSc over there sometime way back in 87, 89. And I still remember all of my teachers who are, many of them are still in touch with me. The education that I had in St. Xavier's College has come in a long way in my profession. Thanks to that college, thanks to the organizers. And let me slow. Why? Just a moment. Just a moment. Yes. This topic, this talk, what I propose to do in this talk is introducing the concept of optimization problems in operation research. Hope I am audible. Sir, am I audible? Hello. Proceed.
Yeah, sir, you are
Proceed.
audible.
Yes.
You can proceed.
And since this is a new topic, my request for everybody, maybe very experienced teachers, senior teachers might be in this audience. My request is to have the mindset of a child, because for most of them, this is going to be a new topic. And there is a disclaimer, this concept of operation research modeling through spreadsheets is found in many management science books. I will show which books I am going to use. Images in this presentation are taken from various internet sources, Wikipedia or others, which are acknowledged with thanks. Example templates are taken from particularly two books to modify to suit our needs. And I thank them. And these are the two books that I will be referring, and from which I have taken my examples. Introduction to Management Science by Hillier and Hillier. This operation research modeling through software, especially spreadsheets, is known as management science. And I have two books to refer. And a mild introduction to operation research. Operation research is a discipline devoted for decision makers. You make certain decisions based on operation research. The OR professionals aim to provide a rational basis for decision making by seeking to understand and structure complex situations. Yes, and this is taken from a website that is acknowledged in the middle. The phases of operation research. I will quickly go through this. This is a certain theory that is needed for completeness. I won't get to details into this. Identifying the problem, formulating the problem, constructing the model, selecting the appropriate input data, deriving the solution, testing the model, establishing control and implementation. Various processes, allocation process, inventory process, waiting line process, replacement process, all this can be covered in management science topic. And What is this? Let me minimize this. Yeah, allocation process, the requirements for these processes are given here. Okay. And what I will try to do in this entire operation research with solving with what is this Microsoft Excel solver is yes, a topic for the entire semester, and it covers linear programming problems, transportation problems, assignment problems, decision making problems, goal problems, queuing theory, and whatnot. Even PET-CPM can be done over there. I will try to address all this with some illustrations. Then I will illustrate, try to work out certain problems. I will try to work out certain problems on hand, because I am not able to do this with a hands-on experience in this. I will try to illustrate what can be done, and then maybe for a LPP and a transportation and an assignment, I will illustrate through a online demonstration. Okay. Let me get into the next slide. These are all the processes that are involved in operation research. So a brief outline of problems that can be modeled and solved with Excel-based operation research. I will end this theory short in a while, this to give an understanding of what best can be done with operation research. Just have a look at it. Finance models you can touch, investment models you can do, production models can be done, purchasing models can be done, distribution and logistic models, scheduling models, decision-making models, transportation, assignment, inventory, and queuing, all this can be done. Okay. But this, why do we do this with a modeling perspective? We teach operation research in colleges. Maybe we are teaching them theory. And when it comes to problems, we do mostly with, what do you say, few variables, and mostly with this x1, x2, x3. Okay. And straight away, the students are not in a position to apply the operation research to real life problems. Okay. So what is to be done to apply this operation research to real life problems is only through modeling. But when you model it, solving can be a difficult task unless you involve a software. Here, I use spreadsheets, Microsoft Excel, to formulate and solve operation research problems. Okay. Small optimization problems can be formulated in Excel and solved with a built-in tool called Solver. I will tell you how to install that built-in add-in. Large optimization problems can be solved with a tool called OpenSolver, which is freely available on the web, or certain software packages, maybe MATLAB and all that. But with MATLAB, you will have to enter the entire problem with variables. Okay. But with spreadsheets, spreadsheet approach for this operation research is very much easy for anybody, including management staff and students, non-mathematicians, to formulate a business problem. For example, one of my students has done real-time work on modeling a wholesale vegetable market for her PhD thesis. Okay. My aim will be to outline the spectrum of problems which can be solved, which can be modeled using this spreadsheets. Okay. Then why this spreadsheet modeling? Spreadsheet modeling is intuitively clear. You can see something on the screen and it is understandable by any non-mathematician also. Okay. You can just show that to a businessman or non-mathematician to understand that. Anything, even simple topics, yeah, bakery owner can be helped with operation research, a hospital owner can be helped with operation research, a multi-storied departmental store problem can be handled in operation research. I will give an outline of all these problems. In this session, I use Microsoft Excel 2007 because my computer has only that solver add-in. But however, you can use even any version of Microsoft Office, and even OpenOffice and the solver. What we covered in this talk, I told you, I will illustrate quickly how to formulate an optimization problem of operation research in spreadsheet to solve, to analyze the problem, give further managerial inputs to the model. Why do I say, why further managerial? You will have a data, okay? With this, you are modeling a operation research problem. For those who are wondering what is this modeling, you must have seen in the first chapter of operation research book, like model the following problem as a linear programming problem. Some word problem will be there, and you will be asked to model it in X, Y, and all that. Okay, then like that, we will have to model real life problems. I will be presenting here caselets. Case studies are bigger ones. Caselets caselets are smaller examples. Okay. This talk will be an appetizer to induce curiosity in the audience and solve optimization problems through spreadsheets. What I intend to cover here, I will quickly outline LPP problems, various varieties, different varieties not seen in textbooks, transportation problems, assignment problems, and if I have time, these first three, I will illustrate with 3 examples on how to work on Excel sheet. Others, I may quickly browse through decision problems, goal programming problems, queuing problems, and if time permits, I will get into PERT problems which can be attacked with this kind of modeling. What is my expectation from the audience? Have some patience to learn this optimization technique and to apply their mind to solve operation such problems through Excel sheet. Okay, many might be even new to Excel. I'm not sure. For the benefits of others, who have some little exposure to Excel, I'll be sharing a crash course on Excel PDF also. The materials will be shared to all the participants through the organizers. And the problem with modeling, if you make a little mistake in the spreadsheet, it might take time to trace where the mistake actually occurred. So enough care must be taken to model operation problems through spreadsheets, for that matter through any software. Okay? Demonstrative linear programming problems. I will first demonstrate a problem. Don't worry, I will show some Excel sheets which I have already worked. Then I will go to the Excel sheet actual and tell you how to model them. Okay. Now let me demonstrate certain problems which I have already solved in Excel for you. We will initially work with problems of 2 variables, but problems of 2 variables seldom occur in real situations. However, a small Excel model with 2 variables can be extended. That I will illustrate. I will take a 2 variable problem, slightly expand it to a 5 variable problem. Okay. Then I will incorporate managerial inputs over their modifications and how to blow it into a bigger problem that I will tell you. Okay. Yes. What do I do? When I minimize this, this gets slower. Problems of 2 variables I am taking now. I am taking a problem now which involves only 2 variables. Okay. Let me, yes. Arrangeable cabinet maker problem. Kindly go through the problem. I have named it so. The problem is taken from that book only. The cabinet maker problem has 12 units of wood and intends to build 2 different kinds of bookcases within 36 hours. You might have seen such problems in what is that operation such book. Model 1 requires 3 units of wood and 9 hours of labor, while model 2 requires 2 units of wood and 8 hours of labor. The selling prices of these models are, I have put it in dollars since I have taken it from the book. And I am in fact writing a book, so I use the international currency, dollar. How many bookcases in each model should the cabinet maker assemble in order to maximize its revenue? Look at this problem. this any operation such problem has a objective. What is the objective of this problem is to maximize the revenue. Done. What is the revenue? The revenue is the number of model 1 multiplied by $150 and a number of model 2 multiplied by $90. That is the revenue. Okay. And what are the restrictions over here? The resources. The resources are a particular wood. We can expand it to any number of resources. A particular wood and labor. Okay. Wood is limited and the labor is also limited. You have 12 units of wood and only 36 hours of labor hour. Now, how to formulate this as a linear programming problem in the traditional way and using what is this spreadsheets? Just to go through this, you may not follow this now, but I will come back to this slide later also. You transfer all data to data cells, display the decisions using changing cells, they are the variables, uncage constraints using output cells. Just I am telling this to understand the terminology. I will actually illustrate this. Specify the overall measure of performance in the target cell, run the model with test values because you are using formulae. Specify the target cell, changing cell and constraints to the solver. After you design it in the spreadsheet, solver you will have to call. Solver is an engine which solves the problem, which is built in, in this Microsoft Excel. Then choose whether the problem is linear or non-linear, run the problem, change what is this numbers to gain insights on the answer, sensitivity analysis and all that. First, what you have to require to do, I will do this on the Excel sheet and show you. First, you will have to transfer the table to Excel sheet like this. Okay, like this. Model versus woods. You see that model 1 requires 3 wood and 9 labor units. Model 2 requires 2 units of wood and 8 units of labor. And the availability is recorded as a constraint. You transfer this to Excel sheet as follows. Now, if you formulate this as a conventional OR problem with the equations for the benefit of our max fraternity who are used to frame this in equations, if this is Z N1, 150 N1 plus 90 N2 with 3 N3, 2 N2 less than or equal to 12, 9 N1 plus 8 N2 less than or equal to 36. N1 and N2 are the numbers of model 1, numbers of model 2 to be produced. But to frame an operation such problem in Excel sheet, you need not to do this mathematical calculation. I am displaying this to enthuse our mathematics fraternity who are used to these equations. Now, what do? I said I must transfer all the data to the Excel sheet like this table. Then I must enter some formulae over there. I will illustrate this shortly. Yes, sum product formula. The sum product formula will be widely used in modeling to operations. Through sum product formula, I must enter there. Then I must add constraints in the Excel solver through certain input to ways of input. Then you see there the solver parameter and the solver options. I will show them now. I'm showing the screenshots. Then after you solve, the solver would say solver found a solution and the answer is displayed below. How do I frame this? This is how I frame this in the Excel sheet. Okay, just have a look at it. I have colored them. Data cells I have colored. Data cells are cells which are given in the problem, which should not be changed in while running the problem. Okay, and then you have a target cell coded with pink. The target cell is the cell which has the objective function, and the yellow ones, you see 4 and 0 there, the yellow ones are the variables, only 2 variables here. How many number of models 1 to be prepared, how many number of model 2 to be prepared. Okay, and this is how it is seen on an Excel sheet. Okay, and then I will illustrate this particular problem how to work on the Excel sheet. Then I will tell you how to explode this further. Let me get back to the working. I will work a Excel sheet and show you now. Okay. What problem do I take? Working. Yes. I am opening Excel sheet. So first I will have to tell you how to install this Excel solver add-in. It is loading. My Excel sheet is loading. Yes, it has loaded there. It has come there. Okay. Let me tell you how to install this Excel solver. If you go to the data tab, there are various tabs in Excel. This version of Excel has this kind of look. If you use Microsoft Office 10, the look may differ. Now, if you look at the data tab, I show you in this, you see a button called solver. Okay. And I have installed Open Solver also here. You see a button called solver. If you click this solver, it is a dialog box is appearing. Okay. Now, how to install this solver? Listen carefully. Go to the Microsoft Office button, the globe in the top left corner. Click that. Then come to the Excel option menu. Click Excel options. Then come to the add-in menu. Come to the add-in menu. In that add-in menu, you will see many add-ins. Click this solver add-in menu. I have installed so many add-ins. Even a tree add-in is there. With this, you can build a decision tree in Excel. Excel will build a decision tree. So the solver add-in, you click and come below to what is this? To click this go button. Okay. When you click this go button, a menu will appear. Okay. In this, you select whatever to be installed, whatever not to be installed. Be clear, be careful to click this solver add-in button and then click OK. I'm not clicking OK because I have already installed it. Okay. So this is how you install the Excel solver. Go to the Excel options menu, go to add-in and then select solver add-in and then install the solver add-in. It will install itself in the menu, data menu. Now, what I have done, I will tell you. This is the data that is available. This is the data. Okay. I have pasted the data. I should actually type it out. Now, for want of time, I have pasted the data there. This is the data with, you see it is in a matrix form, the entire problem. Shall I show the problem once again to you? I will show the problem once again to you. Yes. Just to have a look at the problem. Arrangeable cabinet makers are 12 units of foods. Okay. 12 units of foods and 36 hours are man hours are available. Model 1 has requirements. Just to have a look at it. Model 2 has got requirements. And the selling prices of the models are $150, $90. They are given over here. Now have a careful look at the problem. I am framing this problem as a table. Okay. Let me, yes. This is framed as a table now. Okay. As a matrix. Now I have arranged it in a particular way, but this can be arranged in any way. I have entered the, what is this? Availability data here. These are the available ones over here. Then, yeah, I have entered certain formula here. You see the green ones are variables. Okay. This is x1, x2, maybe n1, n2 for the understanding of people who hang on variables. And I have entered certain formula here. What are the constraints? One constraint is, what is the one constraint? One constraint is the woods, the number of units of woods that is useful in, what is this? That is useful in getting the constraint. How many woods of wood is actually needed? Suppose you produce N1 units of model 1 and N2 units of model 2. Okay. Then the number of units of wood required is 3N1 plus 2N2. which should be less than or equal to 12. Let me show that equation. Yes, you have a look at here. Okay, 3n1 plus 2n2 less than or equal to 12, and 9n1 plus 8n2 less than or equal to 36. Okay, so you need not formulate this as an equation. I will do it in the Excel sheet straight away. Come to the Excel sheet. This is the model. I will do it fresh for you. Okay. Let me copy this and paste it in a new Excel sheet. Okay. I am pasting it a new Excel sheet. Done. Let me erase the, what was that? That was 12 and 36. Okay. Then I will have to enter certain formulae here. What do I have to enter? Just let me maximize this so that you can view it clearly. Hope it is viewed clearly now. See, now I have entered everything now. I will have to enter the constraints. How do I enter the constraints? My said this 3 into this number of bookcases plus 2 into the number of bookcases of model 2 must be less than or equal to 12, right? That is the problem. That is the problem. 3n1 plus 2n2 less than or equal to 12. Okay. Yes. Now, how do I do that? I do it as a sum product function. What is the sum product function? This sum product function multiplies two vectors, okay, of same order, two matrices or two vectors of same order. It will multiply the entries entry by entry, first entry to first entry, second entry to second entry, and then add all the products. Okay. How do I do that? Let me show you. Equal to sum product. That function you must type. Any function in Excel should start with the equality. So equal to sum product, open the bracket, and then mark this, what is this? Wood, requirement of wood, and then comma to be multiplied with the number of cases. So what this has done, D8 to E8 is multiplied with D11 to E11, entry by entry. And then the product is added. The product is added. Let me illustrate this with a trial example. Then this addition must be less than or equal to 12. For example, if I put two units in model 2 and 2 units in model 2, model 1 and model 2, you see that the number is 10. 3 into 2 plus 2 into 2 is 10. Do you follow? 3 into 2 plus 2 into 2 is 10. That should be less than or equal to 12. So if I intend to produce 5 units of model 1 and 8 units of model 2, you see that 31 units of wood is needed. That is not less than or equal to 12. Okay. Let me type the same formula for labor also. The labor must be less than or equal to 36. How much labor is actually needed? Let me calculate using sum product formula. Equal to sum product, open the bracket, and then mark the 2, 9 and 8, the labor needed for model 1 and model 2, put a comma, and then mark the number of bookcases, close the bracket, and enter. You see that when I want to produce, produce 5 units of model 1 to 8 units of model 2, I need 109 units of labor, which is not less than 36. So I have checked the formula now. Let me enter 1, 1 and check the formula. When I enter 1, 1, 3 into 1 plus 2 into 1 is 5, and 9 into 1 plus 8 into 1 is 17. Okay. Now these two have to be filled in by the solver. Here I have marked these two in greens. Here the solution will appear conforming to the constraints. Okay. Now let me get into the revenue tab. What is the revenue? Revenue is, let me, for example, I will enter here N1 and N2 for better understanding. These are the variables N1 and N2. Okay. These are the variables. Now what is the revenue? Revenue is this 150 into N1 plus 90 into N2. That is the revenue. So what I have to do? I have to sum product this selling price cells and the number of booklet cells. Come to the revenue tab, put equal to, enter the formula sum product and then open bracket, mark the selling price columns, comma, mark the variable columns and then close bracket. You need not enter there N1 and N2. I have entered there for better understanding. Usually the variable column is to be left blank. Okay. Now what we have done, I have multiplied the selling price cells to the number of bookcases cells. That will give me the revenue. Let me press enter over there. Let me check it with certain entries. I will put 1 here. Now you see that it is 150 into 1 plus 90 into 1. 240 is showing here. 240 is showing here. Then 240 is coming here. This we have to check the formula whether you have entered it correctly. Whether, because it is a only cursor movement, you might mark certain cells by mistake. So always before running the solver, better to check with the trial values. Let me check with one more trial value, 1 and 2. What is that giving? 150 into 2 plus 90 into 2 is 330. Okay. Now we have framed the model. How did we frame the model? Let me go to that, what is that one procedure I told you. This is the procedure. Now you may follow this. Transfer all data to data cells. Display decisions you changing. What did you do? Entered in certain cells. They are called changing cells. Then engage the constraints using output cells. Okay, output cells where we entered that inequality. Then target cell is the total revenue that we entered. Run the model with the test values to verify the model works in the desired way. Okay, this is what we have done so far. Okay, now let me run the solver to get a solution. But when you go to the solver, you must tell the solver where is what, where is what. Let me go to the solver. See here, the solver, this I cannot maximize. The solver has a certain area to where we have to enter data. First one is set target cell. What you have to do, in that target cell, you click and then what do? You click the target cell, the revenue, the red, I have marked it as red, I have colored it as red. Okay, I will tell you how to color cells later. Click that. So H11 is my target cell. That is the objective function. That is the revenue. That I have to tell the solver that the target cell is in H11. That is 1. Next, I will have to find out whether to maximize or minimize. What is my aim? Let me look at the problem. What was my aim? My aim is to maximize the revenue. Okay. Then I will have to maximize the revenue. So click maximization. So either it is maximization or minimization or value of thing is there. Why that the third option is there? You might not have done this through classroom problem. There can be cases wherein the maximal or optimization doesn't matter, but you will have to spend whatever you have in hand. For example, if your donor donates 2 lakhs rupees to your college and he asks you to spend the entire amount, nothing more, nothing less, you will have to spend the entire amount. Okay, then you will have to click the value of button. Now we are maximizing. Then come to this part by changing cells. What are the changing cells? Changing cells are the variables. What are the variables here? The numbers of model 1 and model 2. So you will have to cover these two. Using cursor, carefully mark D11 and E11. Then let me enter the constraints. What are the constraints? Constraints are this: used must be less than or equal to available. Used labor must be less than or equal to available labor. So let me enter this option called add constraint. Add constraint. You will see a dialog box appearing here. In the left one, you enter the number of used woods. Click at F8. Then there are many options here, less than or equal to, greater than or equal to, int and bin. Okay, int, if you select int only, integer programming problem can be solved. The solutions will be integers. And if you select bin, bin, the entries will be strictly between 0 and 1. Done. Select less than or equal to here. Then what? It should be less than or equal to 12. Mark that 12. Okay. We don't enter 12 there because we may later change it to even 15, 36. So don't enter 12 actually here. Refer to the cell where 12 is entered so that the data can be changed any time. Click add button. The constraint will get added. Second is the number of labor units, used labor units, that is at F9 should be less than or equal to, click in the constraint tab, click at 36, that is H8, what is it? H9, mark that H9 and click add. 2 constraints have been added. Okay. Then now look at the constraint. It says F8 less than or equal to H8, F8 less than or equal to H8. Mark here. F8. What do you have in F8? The total number of woods that are used. 3n1 plus 2n2 is sitting there. Next one, F9 less than or equal to H9. F9 is total number of labors used. 9n1 plus 8n2, that is less than or equal to 36. You need not recall the formula all the time, but the point is you must tell solver what are the constraints. Now I have told the solver the constraints. Now one more option is to be done. Click options, check in linear model and assume non-negativity. This we do in linear programming problems. Non-negativity you must assume, and if the problem is a non-linear problems can also be attacked with the Excel solver, but this is a linear programming problem. Click assume linear model button and assume non-negative button. Need not bother about the maximum term iterations and precision. This will come into effect only when the problem is pretty big. I tell you, with this Excel modeling, you can solve a linear programming problem. In fact, with thousands of variables, hundreds of variables, thousands of variables, you will find it extremely difficult to find a real life problem with those variables. But one example is Olympic Games. The Olympic Games events are, there is a research paper on this, how the Olympic Games events where lakhs of contestants are there to optimize using a linear programming assignment problem. Okay. Now click OK, and then you see the solver is ready now. What we have entered? We first entered the target cell button. When you have cursor in the target cell button, do not click anywhere in the spreadsheet, otherwise that will get marked. Click only at the target cell, okay, H11. Then these H11 and all, these are according to my formulation. If you paste it somewhere, the numbers will differ. Okay? Then tell the variables, tell what are the constraints, go to options, click linear model and all that. Then now click solve, click solve. Now it says that the solver found a solution. You must look carefully what is the message of the solver. Solver sometimes say solver could not find a solution. I will illustrate that. Solver could not find a solution. Okay. Now solver says it found a solution. I must ask for keep the solver solution. And you see certain options here, answer, sensitivity and limits. Click them also. I will tell you what are they. Click OK. Now you see that the answer would have appeared there. See here, the answer is produce 4 models of 1 and produce 0 models of model 2, and the revenue is $600. I will erase the answer once again and run it for you. Okay. Number of bookcases I erased. I am running the solver again. You see it is solved within seconds. Okay. You see 600 is the revenue. Now, how do I, what is the usefulness of this model? I can change the variables. I can change the variable. For example, I say only 12 units are available. Suddenly, there is a lot of inflow of woods. and the number of woods available is 120, 10 times, and the number of labor available 360, 10 times. Okay. Imagine when you do it with a pen and paper, when you give it as exercise student to do it on paper, if you change the constraints, then they will have to rework the entire problem again with a pen and paper. But here I change the constraints. You see the previous answer 40600. Now let me run the program with solver. You see here it is 40, 0 and 60,000. Since I increase it tenfold, this answer is also increased by tenfold. Let me do something else. Maybe the requirement of wood might increase. For example, for model 2, the requirement of wood is 2 units. But suddenly the model 2, there are some modifications done in model 2. Maybe some decoratory item attached to this model 2. Okay, decoratory item, maybe a handle, maybe some doll on the top of that model. So requirement of wood increases now. You see, I am modifying the model now. Requirement of wood increases. It says 5 units needed per, what is this, per unit. Let me get back to the original ones. Okay. Now, let me see whether it gives the same solution. Let me run the solver again. See, it found a solution. It says, again, this don't produce anything of model 2. Don't produce anything of model 2. But my problem says don't produce anything of model 2. But suppose if I want at least one of model 2 and one of model 3, so that I can put it in the showcase. Okay. The problem, it says the optimal solution, of course, says produce 4 units of model 1 and produce only 2 units of model, 0 units of model 2. But the owner says, no, that is there, but I want to produce at least 1 unit of model 1 and 1 unit of model 2. What do you have to do? Certainly the revenue will go down, but you will have to introduce this as a constraint. I will go over there, go to the solver, and I will, before that, I will enter some data here. I want this to be greater than or equal to, I will enter the greater than or equal to symbol there. Okay. Let me find the greater than or equal to symbol. Yes. I entered the greater than or equal to symbol here. This is for our understanding. Whatever symbol you enter here in the Excel sheet is not taken into account by the Excel solver. I am entering this just for our understanding. Okay. Now I want one of this and one of this compulsorily. So you see, I am introducing further constraints here. I want the number of bookcases. Let me again enter N1 and N2 here for understanding. Okay. Let me enter N1 and N2 here for understanding. See here, I want N1 to be greater than or equal to 1 and N2 to be greater than or equal to 1. Okay. Let me erase those N1 and N2. I want model 1 to be at least 1 and model 2 to be at least 2. Now I have entered it in the Excel sheet, but I must tell the solver. How do I tell the solver? Go to enter these two constraints. But I can enter them together also. Let me go to the solver, add a constraint. What is the constraint to be added? This D11 must be greater than or equal to this one, that is 1. Next, this model 2 number E11 must be greater than or equal to this particular one. I am referring to the cell always because this number I want to change anytime. Now I have introduced 2 more constraints. What is that? Number of bookcases to be greater than or equal to 1 all the time. Earlier, what was the solution? 4 units of model 1, 0 units of model 2 with revenue 600. Now I have introduced further constraints now. Okay. Further constraints. Let me change. This was earlier 2, right? I will change it to 2 so that we can compare solutions. Now let me run the solver. After you run the solver, make sure that it tells a solution is found. It says a solution is found. Okay. What is a solution? You see here, number of bookcases 3.1111. No, I don't want 3.11 there. I want integers. Okay. So let me again go to the solver to tell that I want only integers. Let me introduce one more constraint saying that these must be int integers. I want the variables to be integers. Okay. Let me click OK. Let me run the solver again. So what is the answer? It says 3 units of model 1, 1 unit of model 2 with a revenue of 540. Earlier the revenue was 600. Now since I wanted one more unit of model 2, it has gone down to 540. Okay. Now what I wanted to convey through this, given a small problem, you can formulate it in the Excel sheet. You can keep changing. You can keep adding the constraints. Okay. Now let me go for further expansion of these problems. This was the problem. Now you see that kindly go through the procedure, transfer data to data cells, display the decisions using changing cells. Okay. Where is that? Changing cells is the number of variables, N1, N2. You saw that. Then engage the constraints using output cells. You must enter formula to decide the constraints. Then enter the objective in the target cell. Run the model with the test values. Specify the target cell, changing cell, and the constraints to the solver parameter. Choose linearity and non-negativity if needed. Some cases you may have negativity also, but in real life problems we can encounter only with the non-negative problems. Then in options enter this, run the solver, debug or revise the model if necessary. If it is not working the way you wanted, you must debug. Gain insights for the interpretation using answer sensitivity limit report. This I didn't show you. I will show you that what is the sensitivity that we got. While generating the solution, 3 tabs will be selected. One is this tab called answer. It will give you the answer. Okay. Answer in a correct form. Then sensitivity. Sensitivity is how best, how minimum and how maximum the data can be changed without changing the solution. Okay. Now you are mentioning there 150 is the revenue for model 1. Suppose if I change it to 155, will it change? Will it affect the solution? So what is the allowable increase? What is the allowable decrease of the coefficients is found over here. Now let me go to the Excel sheet. Show something. Let me hide this. Let me delete these 2 reports. Let me tell you how to find out to which formula relates to which cell. This is a sheet. Now I will tell 2 things in here. How to color a cell. Coloring a cell is useful in many aspects. One, you won't accidentally touch any cell which has formula. You will be clear for a big, I will show you big linear programming problems. I won't work it out. But where is the data sitting? You should not accidentally delete the data. But you should not accidentally delete a formula. So you need to color them. How do you color it? You go to the home button, go to the bucket menu, select any coloring. Okay. Now you see the coloring coming over there. Next, what do you do? Next, I want to display the formula. To know where formula, go to the formula tab and the show formula option is there in the tab. Click that, formula will be shown. See here, formula are shown. So you can display the formula. You can use it to take a screenshot, use it in your what is this presentation or anything, and you can others can understand where is the formula sitting. You see here some product formula is used there. Where is the formula sitting? You can hide the formula. Then what else you can do? How the formula are related? Go to the formula and then trace precedence. Trace precedence. If I click that, I will select a formula. let me select this formula, then take precedence. So it says this revenue formula is obtained from the selling price rows and the number of bookcases rows. So this is the trace precedent. Then if I come to this one, if I trace precedent, it is telling clear precedence, remove arrows. I will remove them. If this formula you see where it is involved, this formula involves wood row and the number of bookcases row. Okay, let me remove these arrows. Let me trace dependence. Let me select this and let me trace dependent. Which are the cells which are dependent on these cells? Okay, it says this particular cell is dependent on 3 and 2. Okay, so you can use this to find out which are the cells which are dependent or independent of each other. Now, let me expand this problem further. So, what was the purpose of this illustration? To tell you, but still, till you practice it on the Excel sheet, it will be a mystery. But what I have told you, a quick recap of what can be done with the Excel sheet. But usually it needs a hands-on session wherein people sit on my computer and sit on their computer and I explain to them to avoid small mistakes that the audience do over there. But still, I think I have explained this. I will share the procedure also for you to try it at our home. Now, this was what I explained to you. Okay, this was the model. Now, let me, I told you the booked orders, okay, to include further constraints. Let me show you one more, the contradicting constraints. In the same problem, some more constraint is involved. Model 1 would need another thing comes up. The maker has 500 units of lining material occupying much space in the stock room. So what I say, hey, my dear carpenter, you make use of those entire 500 units of lining material in producing these cabinets. I will be happy. Okay. Model 1 needs 6 units of lining and model 2 requires 4 units of lining. Can I exhaust the lining? That is the condition put by the owner. Do you understand one thing in this operations problem? It always depends on the businessman. Okay, the fellow who approaches you for a consultation. The consultation is not there in practice in Indian industries, but abroad, when you begin a business or something, they always go to the management science consultant and consult him whether their model will really work or not. Now this constraint is put over there. What is that? The entire lining material must be exhausted. Is it possible? Let me try. So the formula is reframed like this. Look at the formula. Now I have one more row installed here. Instead of wood, labor, lining is included here. But I am putting equal to here because the owner wants to spend all 500 units. But when I run the problem, it says solver could not find a solution because only 24 units of lining material needed, not 500. So this the entire lining material must be used, 500 material to be used is a contradicting constraint. So while formulating a problem in the spreadsheet, you can also identify contradicting constraints because the owner, the businessman, the model, many constraints. This is a small model on 2 variables. Imagine when you have 1,000 variables, maybe probably hundreds of variables, the interaction between the variables will lead to constraints. This will help you to identify the constraint. So, this one small linear programming problem, I demonstrated how to work. Now, let me get into illustrative linear programming problems, a variety of problems that you might, the teachers and students might not have touched in a traditional operation research course, but this will open up the opportunity to do better case studies. Maybe research can be taken up with real life problems. Okay, let me look at the modifications. This was the previous problem, okay, which we took. Let me expand this. How do I expand this problem? Earlier in this problem, only one wood and one labor is involved. Now I am expanding this problem to involve 5 types of woods: plywood, rosewood, redwood. Okay, I mean, uh, 3 units of wood: plywood, rosewood, and redwood. And the requirements varies, and the selling prices are to be given for 5 models. Now I involve 5 models. This can be easily expanded by just inserting rows. Okay, between a model 1 and model 2, you right click and ask him to insert columns. It will insert columns. It will take care of the formula. Formula will automatically expand itself. So the problem can be expanded. If you do it for 5 models, you can blow it up for 5,000 models. I tell you, may not be there, but you can blow it up to 50 models, 500 models, any number of models, any number of woods can be, the resources can be added, constraints can be added, the variables can keep on adding. Then certain modifications also can be done. Modification 1 is, based on a market survey, the maker feels that he cannot sell no more than 15 numbers of model 5. Sudden input is coming. What do? You insert a particular constraint. Modification 2, it says he wants to produce one model. The regular customer wants to book a case of model 1. See, your optimization suggestions are one thing, but the real life thing is one thing. You may suggest some optimization solution, but in real life, the changes must actually be made. So that is what we do in examinations. Even we do, we conduct examinations, we publish results. That is ideal, but we do modifications through moderation and all. Okay, and in one of my MBA students did a small mini project on his father's what is that company itself. His father produced a certain thing with 2 modes, either in his factory or he used to what is that outsource also. He modeled his entire father's factory, and the optimized solution is, you don't do anything, you outsource everything. Will father agree? No, he won't agree. So the solution may say something, but you will have to incorporate managerial inputs also. So for these 3 modifications, let me show the model. I am showing the model only, not working. You see, additional constraints are included here. Compulsory number is included as a constraint. I told you how to include constraints. Next model, out of this model 1, compulsorily 1 has to be made, irrespective of whether it lowers what is his profit or not. It may happen. See, I am ordering medicines from a medical store, but he may not be selling a particular brand of medicine. But as a regular customer, if I want, he will go and get that medicine, at least 1 unit from my shop, and give it to me. Certainly his profit will go down, but managerial inputs will have to be respected all the time. Model 3, another modification is, every model should have 1, 1, 1, 1, 1 each. Then the revenue will keep on changing. See here, earlier the revenue is 1250. Now one modification revenue is 1200. Another modification revenue is 900. But you are satisfying the managerial inputs. Now let me get into a different problem, a florist company problem. This one, the florist company produces 4 varieties of bouquet made up of different flowers. You know, bouquets are made up with different flowers. The combinations are given here. Okay. Each bouquet, 4 types of bouquet are shown. 4 types of bouquet: corsage, nosegay, posy, and 4 types of bouquets are shown. And in each bouquet, you use 5 flowers, 5 types of roses: Japanese rose, jasmine, a gilliflower, and Banksia rose, and a Bengal rose, all that. Okay, and each of them availability varies. Now you see that this is a different kind of linear programming problem with a broader perspective. Okay. Now, what is my job? For each bouquet, how many units of roses needed, how many units of flowers needed, and what is the selling price of each bouquet is given, and the availability of the flowers are given, cost of each flower is given. Now, what do I have to decide? I have to decide how many units of these 4 bouquets I make up so that my profit is maximized. Okay. So this is framed this way. I am not framing this. It will take a lot of time. I am in fact compressing the entire semester course into 2 hours. Now you see this is how it is formulated. Okay. So a florist problem can be formulated with Excel. Next one, a mixture production problem. When you go to sweet stall, usually many get 1 kg of Mysore pak, 1 kg of mixer and all that. But sometimes what happen, you go to the sweet shop and tell them to put a combination. Okay, a combination of all. Put one piece from each sweet and make 1 kg for me. They usually do it assorted. So this company produces certain mixtures with 3 types of flakes: F1, F2, F3. Okay, when you produce mixture, you see so many things there. Aval can be there, Bengal gram can be there. Okay, now these 3 varieties of flakes, and I make 4 types of mixtures: Madras mixture, Kara mixture, sweet mixture, many. Okay, now the table is given here with certain restrictions on the combination. You see the beauty. These things you may not be able to work out with hand. Now 4 types of mixtures, and in each type of mixture I specify different combinations of 3 flakes. 3 flakes. In mixtures you have got flakes. Enna poduvanga, Omapudi can be there. What is this? The nuts can be there, groundnut can be there. Okay, these are called flakes. In model mixer 1, I say F1 is not less than 20%, F2 not less than 50%, F3 not more than 25%. When you make assorted things, you can specify formula. So for B, for C, for D, you see different combinations. Different combinations. So selling price is given. Now what do I want? I want to know how many kilograms of each mixture I should prepare, conforming to these constraints, conforming to the availability. Okay, the availability is also there. It is given in the bottom. How many kgs of groundnut available, how many kgs of beaten rice available, how many kgs of Bengal gram available, all that is there. So subject to the availability of the flakes, subject to the selling price, subject to the combination, I want to know how much kilograms of mixtures I should produce. Look at the Excel sheet. I have marked it over there. The number of variables is this much. 3 cross 4, 12 variables are sitting over here. And then how many constraints you have to engage all these minimum maximum combinations. You see the number of constraints here, more than 3 dozens, 2 dozen constraints are sitting over here. Now a linear programming problem can be attacked with this many variables and this many constraints. That is what I want to impress upon you. These things can be shared by me. Now let me get into a bigger problem. Okay, just go through the problem, please. This is the urban media advertising problem. The media advertising problem needs also to be optimized. How to optimize this? What is the problem? You need to advertise in various media, various newspapers, dozens of newspapers, dozens of television channels, and dozens of radio channels. And the other modes of advertising are also there. Pamphlets are there. Door to door, you can put pamphlets. Many options are there. Okay, and in each one of these advertising channels, there will be the number of beneficiaries, how many it will reach. The what is it? The hit rate, a TRP rate, and all that. So if I advertise through newspaper, how many will get to know about it? Okay. Now I take, for simplicity, I take 1 newspaper, 1 television, and 1 radio. Okay, and the advertisement costs are given, And advertisement cost will vary on work days and weekdays also. You see the complication, the problem is building up like this. Now, what is given? The number of exposures of newspaper, television and radio is given. The cost of publishing through newspaper, television, radio on weekdays, on working on holidays is given. Now, how do you calculate the exposure? Exposure is given by these TRB rating people. They tell you if you advertise during this serial, you will get this many viewers. Okay? All that data must be collected beforehand. Now, my problem, through which channel I should advertise, and how many units of advertisements must be there. This is really a bigger problem. Look at the problem. This is how I framed this. I have compressed it to tell you the what is this size of this problem. Look at the variables is 3 x 7. 21 variables are seen in this problem. Okay, how much to be advertised in unit 1, day 1, how much to be advertised in day 2, day 3, and all that, and how much to be advertised in newspaper, television, radio, total advertisement. You see the number of what is this constraints over here, a number of constraints, at least 36 constraints are sitting over here. Now, this type of problem, you see now you are getting to know what are the real life problems that can be attacked using operation research. Maybe research can be done on this PhD, somebody can do PhD on this, provided they get all data. Okay, if you come get to know, if you know some what is this multi-storied shopping complex owner, if he gives you data, you can do dozens of PhDs on that shopping mall itself. Now let me show further problems first. A production problem. Production problem is, just go through the problem. A company has to produce 4 products. The plant can produce any product, but the plant 3 cannot produce a particular product. There are restrictions, and how much I can produce given the data. Okay? So this is how it is planned. How much product, what are all the products that the plant 1, plant 2, plant 3 can make. Plant 3 cannot make plant product 4, and what is the optimization. So a production problem can be modeled. Next, beauty of this, the hospital doctor scheduling problem. Not only hospital, wherever you have this shift slot business, you should know how much to recruit, how much to recruit in shifts to minimize the expenditure. For example, you see here the doctors work in certain slots. Okay, 6 a.m. to 10 a.m., 10 a.m. to 2 p.m. 4 hour slots they work, but they come in 8-hour shift. 8-hour shift, and each slot, the requirement of doctors is given as 50, 75, 100. Requirement is there, but the doctors come in shifts. Shift 1 is 6 to 2 p.m. Shift 2 is 10 to 6 p.m. And you see the intersection over here. Do you see the intersection here? Intersection is from 10 to 2 p.m. There is an intersection. So in 10 to 2 p.m., shift 1 doctor will also be there. Shift 2 doctor will also be there. How to minimize the intersection so that I get the minimum number of doctors. This is called a scheduling problem. This is how it is modeled in the Excel sheet. Okay, I cannot elaborate this because this problem itself will take 2 hours for me to explain similar problems. But I want you to understand that scheduling problem can also be done in Excel sheet. I shown you only one demonstration with 2 variables, how to expand it, the cabinet maker problem, but the scheduling problem can be done. Next, a quality checking problem. I am going fast, I know. This quality checking is, a producer makes varieties of electronic accessories, and he has to deploy quality checkers. And you know, quality checkers are of various qualities themselves. More the accuracy, more the charge. Okay, they check it. If you want a 98% accuracy, you need a quality 1 checker, but he charges 20 per hour. If you want a cheaper quality checker charges 5, only $12 per hour, but he can check only limited 42 number of pieces with a 90% accuracy. What do you want? More accuracy, okay? Optimal accuracy with optimal. I cannot I cannot afford to have. What is that? Pay more for 100% accuracy. That is always difficult. We have so many employees in a company. All of them do not have the same efficiency. There will be people with a lot of efficiency. There will be people with some lesser efficiency, but you will have to manage with them. Your company will have thousands of staff. Okay. Now, how to optimize this? For example, if you look at the problem of even assigning papers to teachers, our HODs and principals would have come across this problem. There may be maybe, for example, if you take a maths department, there may be some 20 papers involved, and what is that? Some 5 faculty involved, 6 faculty involved. Each faculty is to be assigned 3 papers, and based on the previous semester's experience, certain faculty will be most suitable for certain papers. Certain faculty will not be suitable for certain papers, but you will have to assign them papers anyway. So how to assign them in a way so as to maximize the satisfaction index of students? This is assignment problem. Okay. Now you understand that the quality checking problem, we can do it this way. I can engage the accuracy, charges, error, the error they make. More accuracy, less error, and more charges, less error, less charges, more error. But you will have to manage with them. You cannot always take quality checker of level 1. Only one will be available maybe. So you will have to give job to other quality checkers also, because they are plenty in number. How to formulate this? I have formulated this and showing it as a screenshot. Then product mix problem. I told you how to mix these products in whatever ratio. You see, certain productions have to be made in certain ratio only. Okay. For example, if you are making a particular cycle, there is a ratio of the nuts and bolts to there must be 2 wheels. Okay. There must be 1 handbar. So handbar to wheel ratio is 1 handbar, 2 wheels, 1 stand, but so many nuts. So you will have ratios in which the products are to be produced. This product mixing problem can also be attacked as a linear programming problem with Excel. Where are these problems available? I told you 2 books, management science books, that describes. I have Indianized them to suit our needs. But such problems are seen in the management science book. 1 or 2 books I will share to you also. So this kind of management science is operation research modeling through spreadsheets. Then a energy sourcing problem can be attacked. For example, I have a building. I need electrical energy. I can get electrical energy through electricity, through natural gas, through solar, this also. And what are the needs? My electricity, heating water, heating space, they are the requirements. I may have fridge, I may have water, washing machine, all that. But even if the what is it, solar energy is cheaper, I cannot have the entire building as solar, because the space in the top floor, vacant space, determines how much solar I can put there. There is a limitation. Okay? There is a limitation. You might have seen in some cinema, the one fellow asking if the apprentices, people, the training people can be hired at no cost. Why don't you hire everybody as a training people? You cannot hire all as training people. There have to be paid laborers. Okay, there can be trainees also. Similarly, I have restrictions in everything. Let me have the model. The size of the roof limits the solar heater. So, but somehow I can get some energy from solar, some energy from biogas, some energy from the actual electricity. Now, how to optimize, how to take into consideration the restrictions, how to take into consideration the benefits, then how much I must produce from each source of electricity. That is modeled as a energy sourcing problem. You see that the energy sourcing problem can be a problem of your college, your institute also. You can just take it out as a MSc project. If it is bigger, you can take it out as a PhD problem also. Okay. My idea of showing all these problems is to tell you the spectrum of problems that can be modeled. Now, maximal flow problems can be modeled. What is this maximal flow problem? To summarize, it will be something like sometimes you will need certain goods, not bothered about the cost. For example, in this area, in this session of what is this pandemic, sometimes you may have to rush all possible available masks to Chennai. Okay, all the possible available. There's a shortage of masks. Then you have to rush wherever masks available. You must rush to Chennai. Then you will send the mask through all possible sources, maximal flow to that destination, not bothering about the cost. So such a problem is called a maximal flow problem. This can be attacked using this Excel sheet. How to maximize the flow to a particular destination from all possible destinations. But sometimes the way of transport might be restricted. Okay, suppose you have to some company is there selling what is this washing machines. Suddenly there is a demand for washing machines in a particular place. You will have to send all washing machines to that place, but the washing machines can be sent through lorry, which can handle, which can house some 20 washing machines. It may send through a van can house only 5 washing machines. Okay, so the transport is limited. Okay, that is what shown here. The mode of transport is limited, but you have to maximize the flow. How do you maximize the flow with the constraints? That is the maximal flow problem that can be handled with Excel, simple Excel. And it is understandable by anybody who looks at this. With a little explanation, they will be able to understand. Then the shortest path problem can be attacked. The fire engine is there. It must reach the destination. There will be so many routes. Which is the shortest route for the fire engine to reach the destination at the earliest possible time. This kind of shortest path problems can be attacked through Excel. You understand? It any problem of any size, the shortest path problem of any size can be attacked through this Excel. For example, when I started teaching here, a group of students approached the speed post authorities to tell them the possible shortest path through which they can deliver the speed post, and they got a certificate from speed post company also. It's a consultancy. So when max people want to do consultancy, this is one of the very good options to do consultancy. So shortest path problems can be attacked. Transportation problems can be attacked. I will come to this short in a while. Transportation problems can be attacked. What's a transportation problem? This also I will illustrate with an example. Okay, so I will come to this a bit later. I will assignment problems also I will do for you. These are only illustrations. This I will show fast. Decision problems. We might have learned the decision theory, the problem of making decision through decision trees. Okay, such problems can be attacked. And there is a add-in in Excel, which is freely downloadable, that builds decision trees in Excel. Of course, with limitations, you can build a decision tree. So what are the decisions that are to be made? Look at this problem. A company produces 3 types of face washes: oil face, dry face, silky face. And based on certain previous experience, potential demand for each product, they may turn out to be good, moderate, or poor. Okay, they are called the states of nature. That comes automatically. You cannot, when you go to market, the things that you come across is the states of nature. And the estimated profit or loss under the 3 states of nature. Okay, see, the states of nature is you think, you do a lot of market research, predict that a product to be good, you float it in the market, suddenly it may turn out to be poor. You never know. See, you produce a particular product with a particular ingredient, Okay. At the time of production, the ingredient may be very safe. You put it in the market. Suddenly, some doctor comes up and says that that ingredient is harmful to what is this health. Then suddenly, upon release, the product may be seen as a poor product. So these are called states of nature. With this, you can construct a decision tree in Excel. I'm telling you, I will just illustrate how to a tree can be drawn in Excel. Okay, so decision problems can be attacked. Another decision problem is a smooth car form decision problem. It tells about the demand, the low demand, moderate demand, high demand for a taxi operator. And what is the strategy to be followed? Should he keep 5 cars or 10 cars or 20 cars? Okay. This problem can be attacked with decision tree. Simulation problems can be attacked. What are simulation problems? Simulation problems are maybe with Monte Carlo simulations, we can simulate a particular event to predict its future behavior. For example, you have a maybe you college. You take for example college. College has a bank branch. There is a branch of bank in the college. Suppose that it has only one teller, one cashier counter. Suddenly the manager says, "Sir, in Prince College, we need to have 2 tellers, 2 cash counters. Rush is more all the time." Suddenly the bank, they won't agree. They will come and check. So they will simulate. What they do, they simulate. They observe the data for a week or so. How many customers come? For what problem they come? Do they come for DD exchange, DD encashment, DD preparation, or withdrawal of money, or just the entry? For list all the purposes for which students come. How do they come? During which hours they come? When the rush is heavy. Okay. So if the rush is heavy only between the lunch hour, then they need not appoint a permanent teller. For that hour, they may hire somebody from the nearby branch. Okay. So we will observe, we will calculate the probability of each event, then we can simulate. So simulation problems can be attacked. The tourist car simulation problem, for example, the fellow should know how much based on how much trips can be there and what is frequency, how much car he must keep. This is one sample. Another, even a barber problem. See, that is a queuing problem. Okay, this is very much similar to the banking problem. A saloon is there. He is not sure when people will walk in, whether they will come for a haircut, whether they come for a shaving, whether they come for a facial. Nothing. You do not know anything. So these can be worked out. Data can be taken. This can be worked out, and to see, you can tell whether the barber really needs an assistant or not. This is how it is framed. I cannot explain this. I'm just showing it to you. Then the goal programming problem can be attacked. What is goal programming? In linear programming, you have only one what is subjective function. In goal programming, you can have 2 objective functions, 3 objective functions with priority. First objective function, second objective function, third objective function. And you can attack in queuing problems. You can attack what is this preemptive nature also. In queuing problems can be attacked in this Excel sheet. But in queuing, there can be priority also. So suppose you have a big queue. Suddenly the person in the queue may be known to somebody in the company. He will break the queue and go over there. That is priority. Okay. So priority queues can be attacked. Goal programming, queuing programming can be attacked. So what do I do? Now I told you I illustrated a linear programming problem. Now I will illustrate a transportation problem. How to attack a transportation problem. Let me come to that. I will illustrate how to actually work out a transportation problem. Yes, sample transportation problem I will take first. Practice sample transportation problem. Yes. Let me see this transportation problem. It's opening. Since I am told that the audience comprise of mathematics faculty, I am not getting into detail telling what is a transportation problem. In short, transportation problem is to transfer goods from the production places to the distribution places. Okay. Let me show a transportation problem, for example. This is the transportation problem. I will work it out for you. How to model a transportation problem in the Excel sheet. So this is the problem. Right. Do you see it? Is it big enough? Right. See the plants. There are 3 plants, and it should be transferred to 5 customers A, B, C, D, E. And the cost of transporting from each plant to each customer is given in this matrix. Okay. My research student, in fact, attacked a transportation problem with nearly 50 plants and 100 destinations. Okay, so such big problems can be attacked, real life problems. All you need is data, but I tell you, collecting data is a headache. Data is not easily available, but when you succeed getting the data, you can solve any real life problem. Now, let me tell you how to solve this transportation problem on the Excel sheet. I am copying this and pasting it in the Excel sheet for convenience. Let me open an Excel sheet for you. Okay, let me open a new Excel sheet. What do? I am typing the problem now, so I am pasting. Done. So you do this first. Then what do you do? Okay. You have to enter the supply and demand. Supply is 60, 35, 40. We will come to that. Let me. Yes. What do you do? First, you enter data like this. Procedure is simple, like that of a linear programming problem. What do you have to do? You have to copy and paste the same table below it. Okay. Then what do? You erase this cost matrix. Leave empty. So what is an empty space? Empty space is the variables. Okay. Then you will have to put in the, what is this supply and demand. Let me look at the supply and demand. Supply is 60, 35, 40. Let me enter them. 60, 35, 40. Okay. 60, 35, 40. I entered them. Then let me enter the demand. Demand part is 22, 45, 20, 18. Let me enter 22, 45. 22, 45. Next one is 20, 18, 30. 20, 20, 18, 30. Done. So, for sake of convenience, I am centering all these entries. Done. Now, I have entered the data. What is required? How to, I have to put this cell below. Right. Now, what is the requirement? When you transport from this plant, the sum of all transported from plant 1 cannot exceed 60. Cannot exceed 60. So, this is the sum. Sum of everything that is transported from plant 1 cannot exceed, or maybe I should say equal to 60. Let me see whether this is a balanced problem. If it is an unbalanced problem, I will use less than or equal to. Okay. So I can drag this formula here. I can copy and put equal to here. Okay. You see here the formula is summed here. Let me put the sum here also. The sum of all received things to A from plant 1, plant 2, plant 3 must be equal to 22. Must be equal to 22. Okay. Let me see whether it is a balanced problem. If it is not a balanced problem, I will, what is this coming? Yes. I assume that this is a balanced problem. Let me check. I can check it also. Okay. Now let me drag this formula. What is I have entered here? Just to see here, I have entered sum of the things that are delivered from plant 1 to A, B, C, D, E. That should be 60. I am saying. Now let me check whether this is a balanced problem. Let me put here the supply, total supply. Let me see supply. Supply I put here. What is this? This is equal to sum of 60, 35, 40. Okay. Let me put demand. Demand is equal to sum of all these demands. Let me see whether this is a balanced problem. This is a balanced problem. So I will have equality. Suppose if this is an unbalanced problem, suppose the supply is less, then you should use less than or equal to there. That's all. That is the difference. Now this is the, I have checked that this is a balanced problem. Now I must enter the target cell. I am coming to the closer of the solution. Target cell is the total cost. What's the total cost? Total cost is the product of the cost matrix and the solution matrix. So this is some product. How do you calculate the cost? Each cost into multiplied by the each solution, each transporting item. So I should mark like this: some product of the cost matrix, some product is applicable to equal the matrices of equal order, comma, and then I must mark the solution matrix carefully. Okay. So I have entered here the formula. Look at the formula. Let me look at the formula. It is the cost matrix into C. Suppose if I transfer 1 from here. Okay, 1. Okay, if I do like this, see the cost, it is 10. Why? This 4 into 1 plus this cost 3 into 1 plus this 2 into 1 plus 1 into 1 gives me 10. So I have checked it with ordinary values, trial values. Now let me go to the solver. What did I do? I have now emptied the space for variables, checked whether this is. Now let me go to the solver. Now in a second this will be solved. Go to the solver. What is the target cell? The target cell is, let me minimize this so that the entire screen is visible. Go to the solver. What's the target cell? Target cell is the cost cell. Okay. Target cell is the cost cell. And what do you want to do? You want to minimize the transportation cost. What are the changing cells? Changing cells are the 15 empty cells. Okay. What are the constraints? Constraints is this actual supply must be equal to the original supply. I can enter them together. Then the actual supplied to the customers must be equal to the original demand. Okay, I can do them one by one, or when there is equality throughout, when the inequality doesn't change, you can cover all the 5 cells together and compare this row with another row straight away. So let me say okay. Let me go to options, select linear model, select non-negativity. Okay, let me solve it. It says solver found a solution. What is a solution? The solution is this: transport 45 from plant 1 to B, 5 from plant 1 to D, 13 from plant 2 to D, like that, and the cost is 228. Let me erase this once again. I can erase this and run it and show you. See, everything is blank now. Go to the solver, run it. It gives you the solution. Okay, so this is how a transportation problem is attacked. Okay, now in this you can change the variables. For example, Let me make it as a unbalanced problem. Let me reduce the 60 to 50. What happens? The supply has gone down. Supply has gone down. Supply is 125, demand is 10 units more. Then what will actually happen while you do it in class, you introduce a dummy plant and dummy customer. No need for that. Here you will have to change it as a variable. Now what will happen? Supply will be exhausted. Supply will be exhausted because supply is minimum and demand is more. Some customer will receive less than the demand. Some customer will receive less than the demand. So what should I do? I should replace these equalities with inequalities. That's all. Where is that insert? I will insert the lesson or equal to symbol here. Okay. For understanding only. This is for whatever you do on the Excel sheet is for understanding only. You must incorporate it in the. So when this is an unbalanced problem, put to everywhere inequality, and you will have to change it in the solver. Where should I go to the solver? If I go to the solver, which is the inequality? It is E15 to H15. E15 to H15, I15. This to be changed. This to be changed as a less than or equal to symbol. Done. Okay. Now this gives the solution for you. See here, 50 exhausted, but who received less? Customer D, instead of 18, he is receiving only 8. All others getting equal now. So if it is an unbalanced problem, engage inequality. If it is a what is this balanced problem, you indicate by with inequalities. So let me get back to the production. Allow some 10 minutes for questioning. Yes, just a minute. Yes. So I told you the varieties that can be covered with this transportation problem. Assignment problem is similar. I tell you, I just show you that assignment problem you see, it is very similar to the transportation problem in model. This is one assignment problem. In classical assignment problems, you assign in our classroom one machine to one job. Now here, one machine can be assigned 3 jobs also. So this is the model. 4 companies are bidding for the school bus routes, 4 routes, and there is competition in each route, and certain companies cannot take certain routes. Now, depending on the model, how do you frame this as an assignment problem? You frame this as an assignment problem just like the transportation problem. This is how an assignment problem can be framed. Okay. So let me get back to the sheet wherein I told you what are all the problems that can be attacked. Okay. I covered this. What is this? Linear programming problems, transportation problem, assignment problems. I worked out for you how to do them. Decision problems, goal programming problems, queuing problems. I just showed it to you, that I am skipping. I do not have time now. Okay. Now the session is open for any questions. Let me conclude by this. What is the use of learning operation research through spreadsheets? The advantage for teachers, it is an ICT tool. If there are 100 students in a class, if there are, I will display my contact information just for you to go through. If there are 100 students in a class, what you can do, you can frame 100 questions. You can frame 100 transport problems. You can frame 100 assignment problems. Anything random, you have the solution in your hand, you can throw it to the students, so they can work it out. Secondly, for students, they can check the answers of textbook problems, and for researchers, they can get hold of any real world optimization problem to attack through this operation research models. I showed you a different model. You can simply work it on a bakery also. Let me tell you, there is a bakery near your college. You go to the bakery, find out, help him to find out how much samosa he must produce, how much bread he must produce, how much cake he must produce based on the demand, based on simulation. Okay. So a number of lifetime problems can be taken up for mini projects, and a bigger problem can be taken up for even research. Very big problems, let me tell you, problems of thousands of variables can be handled with operation research modeling. Thank you. Let me come back to the Zoom studio, start sharing my screen. Yes, if there are questions that can be taken up, I will share all this material to the participants through organizers. I'm afraid I was fast, but I think I could at least explain the linear programming problem, transportation problem in detail. Yes. Yes, voice is not clear. Recording will be there. Recording, I think it is on YouTube. Yes, any questions, organizers can come online, please.
Yes, Lakshmi. Hello.
Yes, echo is seen. Yes. Any questions?
Lakshmi.
Let me have a look at the questions.
Yes,
Hello.
yes.
Yes, sir. Yes. Hello.
Yes.
Dear. Hello.
Yes, madam, you are audible, but echo is heard. If you have two devices, kindly mute one device.
Hello, sir.
Yes. Yes, madam, please proceed.
Hello, sir. Hello. Sir, it is not audible here. Hello. Hello, sir. It is
Yes,
not...
am I audible?
Sir, hello.
Am I audible to others?
Yeah, you are audible. You are audible.
Madam, keep saying I'm not audible.
Yeah. Sir, no. Hello. Yeah, it's audible now. Yes, it's audible now.
Yes.
Any questions from the participants? Any questions from the participants?
Can someone
Mr.
give me the
Tamil
name
Selvan
of...
has raised hand. We will unmute. Okay, Mr. Tamil Selvan, you unmute yourself and then you can speak.
Yes, sir. Sir, Tamil Selvan speaking, sir.
Yes, sir. Good morning.
Sir, good morning, sir. Very nice presentation. And sir, I want to know whether the LPP have the same lesson or equal to inequality or greater than or equal to inequality.
Anything, sir. Anything. Because it is, you are going to apply it only solver. Indeed, there is no difference between the two-phase method, simplex method, all this BIGAM method.
Oh, BIGAM also we can solve.
You can use combination of equalities, inequalities, anything, sir. Any number of constraints, any combination of the operators.
Okay, sir. Thank you, sir.
Absolutely no problem. But not enough to put it on the spreadsheet. Put it in the solver. That is important.
Okay, sir. Okay.
Yes. Next.
Sir, for transportation problem, minimization, everything we can solve.
Sir, minimization, maximum, both are possible. Specify it in the solver.
Okay. It follow Vogel's approximation or some other technique, sir?
This one. I think the built-in algorithm follows only whatever we follow in the textbooks. But it is not explicitly shown. The algorithm that the solver does is not explicitly shown. But I think it follows the same algorithm that we follow.
Okay, very nice.
Not this, I mean, how does it calculate the basic one cannot be found out. It can be some advanced, what is that algorithm also.
Okay, sir. Okay.
But it does it in fraction of seconds. You would never have time to observe.
Yeah, this is the first time I saw using Excel. Excellent, sir. Excellent, sir. You were given very nice. Very nice.
I have been doing it for past 10 years. Wherever I go, I want to popularize this. Yes.
Thank you, sir. Thank you very much.
Any further questions? Let me see the...
Dear participants, if anybody else is interested in interacting with Dr. Venugopal, you can raise your hand. Dr. T. Bharati, we have unmuted you. You have to unmute yourself now and then you can speak. Dr. Bharati. Dr. Bharati, unmute yourself and then speak. We have unmuted you. Dr. Bharati, unmute yourself and then speak.
Bharati madam can come online.
We have unmuted you. You have to unmute you and then you have to speak.
Click on the mic icon.
Mr. Ramkumar, you can also, yes. Mr. Ramkumar, I think you have unmuted yourself. You can speak.
Yeah, sir, it was a very nice session. Excellent presentation, sir. Yeah, as being a HR faculty, hope you know we don't have exposure in this quantitative techniques and all. But still, as I'm teaching HR analytics and HR metrics, I'm trying to use this model, even including simulation model for HR requirement, workforce requirement and all.
Yes, sir.
So today we cannot say that HR faculty should not know escape from this quantitative techniques and all.
Correct.
So
correct. You must know.
My request is there any specific tools or techniques for this HR analytics, HR metrics related things, especially in tools I'm asking?
Tools,
manpower requirement kind of things.
You want decision tools?
Yeah.
There is a decision tool in built-in Excel.
Okay,
so,
sir.
One observation is the way we math teachers, sorry to say, teach operation research to this MBA student is through pen and paper with mathematical calculations, trying to frame the problem into equations. But HR people can learn with this kind of tools. For example, Excel solver has only certain things. You must have a objective, you must have constraints, and you must have a variable cell. That's all. These are the only three requirements. So whatever be the problem which meets these three requirements can be solved through this. Not only linear programming, not only decision making, PET CPM can be attacked, flow problems can be attacked, goal problems can be attacked. Okay, whatever be the problem, if it fits this particular limited resources and objective function and the constraints, if these three things are there, any problem can be attacked without reframing it into a set of equations. You can just do it on the Excel. I showed you the media advertisement problem, scheduling problem. All such problems can be attacked. No separate what is this analytic tools over here. Only solver is available, and you will have to suitably frame your problem in the Excel sheet to attack it through solver. Non-linear problems can also be attacked. I will need some demo, hands-on session to get into all this. This is new to me. I have been doing it on a hands-on session, but a variety of problems can be attacked. There is no doubt. If you present your problem, I can tell you whether it can be attacked with Excel solver or not. Okay. Yes, any further questions?
Dear participants, we have posted a feedback link in chat box, so you can give your feedback. I think Mr. Ramkumar has come out with his query, and then Dr. Bharati.
Somebody asking question whether graphical method is possible. The entire thing is graphic. There is no need for separate graphical method over here. Graphical method is applicable only for two variables. This can be done for any number of variables. Okay? There is no need to visualize this with graphs. Two variable problem can be attacked in this, but not necessarily drawing graphs. But two variable problems can be attacked.
Dr. Bharati, unmute yourself and then speak.
Yes, she has been trying to ask question.
You have to unmute yourself and then you can speak. You have raised a hand. We have unmuted you. You have to again unmute and then you can speak. I think there is no other participant raising hand. So still we see Dr. Bharati hand raised. We have unmuted. So you click the audio symbol, then you unmute yourself, and then you speak. Dr. Bharati. It was,
Bharati is saying it was a good session.
yeah, very
informative. That's all.
Okay, okay. Anything
No
else?
questions.
No question. Okay, then
Any questions from my teachers?
dear participants, again and again we are posting a feedback link in the chat box to give your feedback. Sir, there is a question. Can we solve a dynamic programming problem? Vasudevan has raised this question.
Yes, I have tried it, not directly. You can solve a dynamic certain dynamic programming problems with this. Okay, because it can be converted into a linear programming problem through duality. It is possible. It is possible. Certain problems can be attacked. I tried.
Now, Subbalakshmi madam,
Yes, sir.
you can propose vote of thanks.
Yeah, yes, sir. The roots of all goodness lies in the soil of appreciation for goodness. So it's time to appreciate and acknowledge each little step of every little heart to make this webinar a meaningful one. Foremost, my heartfelt gratitude goes to Reverend Father Dr. V. Henry Jerome, hiding soul of this universe. And next, my gratitude goes to Reverend Father Dr. Alphonse Monicum for his valuable guidance. And also my heartfelt gratitude goes to Reverend Father Dr. Principal Dr. Mariadas for all his support in various forms. It is not a title that honor men, but men that honor title. This words of wisdom from Nicola personifies the resource person of today's webinar. It was highly resourceful session. We are thankful for you to share your expertise with this. Sir, this is not just 2 hours, but hours of a lifetime. So we are very grateful, we are very thankful for your valuable time to be with us. Thanks a lot, sir. Then my heartfelt thanks goes to convener Dr. Arul Raj, HOD Mathematics Department. Also my heartfelt thanks goes to co-convener Dr. Prabhaharan, coordinator shift 2. Also I would like to thank my professor Dr. Lulu Swami sir, co-host for this webinar, and also my thankful to all the participants and faculty members from various institutions. Once again, my heartfelt thanks goes to all those little efforts put by each and everyone for making this webinar a meaningful experience for each and every one of this session. Thanks a lot. Once again, a heartfelt thanks to everyone. Thank you.
Thank you. Thank you to my teachers in St. Xavier's College, my past teachers, Maria Rolindaraj sir, Mathinganaya sir, Shanta Kumaran sir, and everybody who taught me MSc course in St. Xavier's College. Thank you, the participants. Thank you, the organizers.
Thank you, Dr. Venugopal. Thank you. Dear participants, kindly fill in feedback form, submit your feedback, and then you click the link button which you find at the right bottom of the screen, Zoom screen, and then you leave the meeting. I think all of you have given your feedback. So, feedback link you see in chat box. Dr. Teresa Sunira Mary and myself, both of us are posting feedback link in chat box. Submit your feedback and then you leave. Subbalakshmi madam, thank you for moderating the session.
I am thankful for you. Thank you.
Dear participants, the Zoom portal will be kept open for some more time, for 5 more minutes. you kindly submit your feedback and then you click the leave button and then leave Zoom for